Welcome everyone. I don't know how was the last section of our lesson. I hope it actually went well. Well, today I want to give us a quick review on static. We actually did something in our last lesson on static. Now, this is just a quick one. A static, as we said in our last lesson, is defined as a branch of mechanics which deals with the study of bodies at rest being acted upon by a force. Like in our last lesson, I stated something that, let me say, for instance, you have a table with a cup on a table. Let me say this happens to be the cup. This is a cup on a table. A cup being on the table, there are certain forces acting on it to keep the cup on that table. Some are acting this way. The cup on its own is acting this force down, while the table is trying to exert a force to the cup in the upward direction. So what we're trying to talk about now is a static deals with the total number of forces that is being acted towards a particular material that is kept at a particular point in time. So when we're talking about static, we are talking about the effect of forces on an object that is at a point. Now, you can't talk about statics. We made mention of this in our last class, that you can't talk about statics without talking about the moment of a force acting at a point. Now, why the importance of talking about moment of a force is because, the closer the force to a particular object, the higher the effect the object feels from that particular force. So when you talk about moment, you say moment of a force about a given point is the turning effect of a force about an axis through a point. That is the product of the force and its force arm. Now, when you're talking about the force arm, you're talking about the distance of the force. So that is why when you're talking about moment, you're simply talking about force times its distance. Now, you're trying to talk about this in this area. You're talking about the force, just like what we mentioned here when we're talking about statics. The statics deals with the influence that is being felt by a body as a result of its state of being at rest. Now, when you're talking about moment talks about the distance, the direction of that force from the object of which it's being acted upon. So that's just all about moment. And the unit for this is Newton meter, because the unit for force is newtons and that of distance is meters. So if a system of coplanar forces is in equilibrium, then the sum of the clockwise movement is equal to the anti-clockwise moment about the same point in the plane. Now, I want to explain something. If this is a point and we have an edge that is holding this, there are two things that are holding this. This is just a point source. Now, certain things need to happen at this point. A force at this point is trying to drag this same stuff down, which is acting in this direction. But what is keeping it? And you know that since it's acting this way, there's another force again that is acting in this direction, that is trying to press it in this direction. So let us say this force is acting downwards. This other force is also acting downwards. And when this force acts in this direction, this one acts in this direction. Now, this particular material will be kept constant, because this force will be equals this force. Let me say we have 20 Newton and we also have 20 Newton. Now, you notice that this is the anti-clockwise direction. Anti-clockwise. And this is the clockwise. Okay, this is a clockwise direction. Now, with this effect, you discover that for this thing to be at rest at this point, the sum of the clockwise movement should be equal to that of the anti-clockwise movement, and that is when you experience an object at a point being in equilibrium. So let's move further into solving a particular example, just like we did in our previous lesson. Let's call this example 1 for today. Okay, Now the question goes this way. I told us in our last class that each time you want to solve a question like this, you pick out the parameters that is being needed to enable your work to flow freely. Now the question is a uniform plank. Now for it to be called a uniform plank, XY is 16 meters long and has a mass of 18 kilogram. Okay, now let's produce our plank. This is our uniform plank, and the distance from here, okay, let's use this point. We are drawing it this way, we are still producing it this way, so we want to project it from here to here. From our question is 16 meters. It's 16 meters long. Now this is the length of the plank, 16 meters. Okay, and they said of mass 18 kilogram. If that is the mass, then we come to the middle of it and place the mass, which is what? 18 kilograms. Now this is the mass of the plank, but remember there should be an edge holding that. The plank rests on two support, X and Y. Okay, let's call this the plank rests here. Let's call this point X. It also rests here. Let's call this point Y. And a load of mass 8 kilogram is placed on the plank at a point Z, which is 6 meters away from X. Okay, if this is 16, let's take from here, this midpoint should be 8. So 6 meters from X should be from here to here. Now they said we have 8 kilogram somewhere here, kilogram, and here remember is 6 meters from the question. 6 meters. Now calculate the reactions of the support at X and on Y on the plank, taking acceleration due to gravity to being 9.8 meters per second square. Okay, now we want to check the effect, the reaction at this point, and a reaction at this point. And remember the rule, like we discussed in our previous lesson, that the sum of clockwise movement should be equals this is clock, and should be equals the anti-clockwise. So with this, let's deal with the reaction at X, but let's represent Rx to be the reaction at point X and Ry to be the reaction at point Y. Now let's go into detailed solving. We have some of reaction at X, which is we have Ry, which happens to be a reaction, times the total reaction in this direction is 16. That is the length, or the total length of the plank, is equals. Now let's take all the reaction that took place. We have 6 and 8 here, so which is 8 times 6 plus, we also have 18 and what? 8, which happens to be the middle of the plank. So we have 18 times 8. So if this is the middle of the plank, so this point is 8, this point is 8. Let's say this is the middle where the 18 was being placed. So with this, we continue by saying 6 times 8 is 48 plus 18 times 6 is 18 times 6 is 144. So with this, we have it to be equal to, remember we are dealing with grams, so this is 18.6 gram, which is equals 192 G. So, and remember the value of our G was given to us to be 9.8. So we now have 192 times 9.8, which is equals 192 times 1 is 1881.6. But the value of our Rx should be equal 1881.6. remember we have this times 16 here, so it should be here divide by 16 and here divide by 16, so that this goes with this. So Rx becomes 1881/6 times this, which is 117.6. so our Rx is equal 117.6. this is a value of Rx. Okay, now let's go into checking that of Ry. Remember the same rule, should be Ry times 16 to be equal to, now from our previous slide we had that the reaction here is 8 and 18, then we also have the middle, which is 8 and 18, then 6 point this. So we are moving further again into saying that this is 8 times 10 plus 18 times 8. That's the reaction in this other direction. So we now have 80 plus 144. Remember this is G, this is G, so which is equal to 224 grams. Acceleration due to gravity, G. But remember, acceleration due to gravity is equals 9.8 meters per second square. So with this we have our Ry to be equals, 16 Ry to be equals 224 times 9.8 all over 16 all over 16. So this goes with this. So we have the value of our Ry to be equals 224 times 9 over 16 to be equals to 137.2. So with this, reaction at point X is equal to 117.6, and the reaction at point Y is equals 137.2. I think with this is a fast this is just a fast one that will help us into understanding more to what we had in our last class. So I would like you to refresh your memory on what we've just discussed. Check the test on the screen. Do well to use this lesson note on the platform for a better information on the topic we've discussed. Feel free to always drop a question on the comment section, and it will be attended to ASAP. Thank you. We'll meet in our next lesson.